Hello guys, in this video we are going to talk about IP address, MAC address and port address. With that we are also going to cover a topic named switching techniques. So first of all, let's talk about what IP address basically is. So the full form of IP is Internet Protocol. As per you can see here, every node or computer in a network is identified by IP address. Alright, now IP address is a logical address cause it will be provided to you via a logic, and that's not a permanent address that can be changed. Alright, that changes basis on the basis of your location, of the location of your device. Okay, IP address is assigned manually or dynamically. Okay, now IP address is represented in decimal and it has 4 octets. This means that this will be like something like this. And remember a thing that look, here's 255. Now the numbers in these 4 octets, in the first one or the second or the third or the last, will never exceed 255 and will not be less than 0. Okay, they are going to start from 0 and will be maximally 255. They won't exceed this number. Between that it can be anything. It can be 11 11 11 11 or something like that. Okay, now what IP address basically does. So IP address is basically going to give an identification to your LAN. Now suppose you are working in a building. All right, now at your floor your company is using a LAN. Now your entire LAN will be assigned to a unique IP address. If supposingly that will be suppose it is, uh, let me give you an example. Coming here, IP address and searching here you can see here, if we look at this image, suppose this is a LAN. All right, now you can see the first one of the IP addresses are same for each and every computer, like 192.168.10 dot up to this entire the IP address of entire network is same, and of this LAN. Afterwards it's changing. It's 24 for this, 25 for this, and so on for all these computers. So this is what I mean. If your LAN is going to be identified, suppose this, whatever data you will be getting for the server, from the server, that data first will approach to this device, cause this device carries the IP address 192.168.10. Okay, so the whatever the network, whatever the data will be, it will first reach to this device, then it will reach to you. All right, coming back to topic, what else? IP address IP address gives an identification to your LAN, and I guess this is enough for right now. We're going to explain it further after reading MAC address and port address. So let's begin. MAC address. Now MAC address is medical access, media access control. In a LAN, every node is identified with MAC. I'll explain it to you later. Just look at this first. IP address is the location of a person. As I told you, your entire LAN will be denoted by a unique IP address. Alright. Now in that IP address, there are several computers. Suppose there are 5 computers. Now each of the 5 computers will be having their own unique MAC address. Now that MAC address won't be allotted to any other computer in this world. Alright, let me show you. Look, if they are all these computers, the IP address might be same for everyone. If server is reaching to this network, then it will only be required by it will require this IP address to reach up to this point. However, how to know which particular machine order or requested for that data? Now that will be dealt with the help of MAC address. So just for letting you know, this entire network will be having an IP address of its own, okay, but each and every computer will be having its unique MAC address, okay. Now what does it mean? Suppose I am requesting for a data. Suppose I requested a YouTube video. The server will see that something 192.168.110, not this 24. It will see the IP address of this, and then it will see that this is requesting a video. So simply it's going to send the video, and afterward it reaches this node. Then it will see which particular computer ordered for that or requested for that data. Then with the help of MAC address, it's going to identify it and send the data. All right. Now it's a physical address. It is unique. It cannot be changed. As per we read in IP address could be changed according to your location, where your LAN exists. If you are in your society, then that will be different from your office LAN. All right. Now it is assigned by the manufacturer. It can be represented in hexadecimal. Example of a MAC address is like this. It is a 48-bit hexadecimal number kind. It is like 70 and 20. This, okay. This hyphen thing could be replaced by columns, by full stop or something else. This depends on the manufacturer. Okay. So I guess it's enough for MAC address. Now moving on to port address. Now you see, your LAN network is identified by IP address. Which LAN is requesting data will be identified with the help of IP address. Which device is requesting data with which will be identified with the help of MAC address. Now in that device, in that particular device, there are so many applications. Now which application is demanding for that data? That will be addressed with the help of port address. Suppose you sent a message to your friend through WhatsApp. All right. Now you are in your PC. You are running WhatsApp. You are running YouTube. You are running Google. You are running several other things. How would they identify now which application is requesting for the particular data? This has to be some sort of mechanism for that. Has to be some kind of identification for which application. Every application should also having their identification, right? This is the identification. So if if you are requesting something from Google, then it will be having its own unique port address, and that data, after entering your MAC address, that is after entering your computer, will find that application with the help of this port address. All right. How it will get your port address, how it will get the data, how the data will get your MAC address, how the data will get your IP address, we are going to talk about everything later. First just see what this port address and accept other things does. All right. Coming forward, port is the communication endpoint. Of course the communication is going to end on this. All right, on the application which requested for the data. All right. Now example port 80. If some of you have ran localhost, if you haven't, then no worries. However, you must have seen, if you have ran the localhost, that is that whenever you run your application, your website, if you are making some kind of website, then it runs on localhost 80. Now that 80 is a port number that you are using in your computer for that particular application. Now if you are sending some data, then the device to whom you are sending will know that this data is coming from port 80. I have to send the response back to port 80. All right. Now there are ports between 0 to 65,000 and 535. This is the a number of ports, maximum number of ports, from 0 to 65,535. All right, each application has a port number. Okay, so this was about IP address, MAC address, and port address. All right, now further at the end, elaborating you things. So suppose now this, so suppose this compute. So now let me give you an kind of illustration about, kind of an example about what it could be, an analogy. Suppose in your family you ordered some parcel from Amazon. Now the Amazon guy will come to your home, come to your kind of, you live in a flat. Suppose you live in a flat. Now that flat's address will be the, so suppose that is the IP address. Now your parcel at first is going to reach your flat with the IP address. Okay, now it is reached to your flat. Fine. Now how it will, how what I'm sorry. Now how will it is going to find your home? That home address, suppose that home address to be the MAC address. He reached your flat with the help of IP address. Now further he is going to reach your home with the help of MAC address. Okay. Now in when he reached your home with the help of MAC address, how that person is going to know which certain member of your family, of course you must have some members in your family, right? Now which particular member ordered that parcel for? How is that guy knowing, how is that guy going to know about that? Now to know that, suppose that thing is going to be the port address, which particular member ordered for the parcel, that thing is going to be denoted by port address. All right, so this was the analogy. IP address helped to reach you, to reach that date, that parcel, to a particular LAN network, particular society, particular area. After that, which particular family ordered or particular home ordered that particle, sorry, that parcel, was identified with the help of MAC address. And afterwards, which particular member ordered for that parcel was identified with the help of port address. All right, so yes guys, this was about IP address, MAC address, and port address. Moving further, now what are switching techniques? What basically switching is? As I earlier told you that there is not only one way to reach your destination. If you are sending some data or receiving some data, there is not only one route. There are multiple paths. So which path is going to be most suitable for you? Deciding that thing is switching. It's written over here. Switching in computer network helps in deciding the best possible route for data transmission when there are multiple paths in a network. All right, this makes you give a feel of one-to-one connection. Okay, now various switching techniques. There is circuit switching. At very first there is circuit switching, there is message switching, there is packet switching. Packet switching further has two types: datagram approach and virtual circuit approach. We are going to discuss all of them in detail. So I hope you are clear with switching. Now let's move to circuit switching. What circuit switching is: a dedicated path is established between the sender and receiver. A connection is established before data transfer. Now, a very good example for this circuit switching is telephone network. Suppose you making your friend a call. Now, when you make a call, a particular connection is first established in between you and your friend. Then, data what you will be sending via your mobile, like you're speaking something, that audio as a data will reach your friend. So first connection was established, then data went from your side to his side or his side to your side. The data sharing is being processed, and afterwards when you are done with your talking, you will disconnect the call. That is, connection is disconnected. Now how connection is established? Suppose, okay, now when you call your friend, at very first you are kind of sending a request to your friend. You're calling him. When you're calling him, it's kind of a request that is being transmitted to him. It depends on him whether he accepts the call or rejects the call. All right, so that is a connection establishment. If he accepts the call, then a connection will be established, the first process is complete, then data will be transferred. All right, so this was about it. Here are the three phases: connection establishment, data transfer, connection disconnection, that I told you earlier. Look, in this path, in this circuit switching, the path is fixed, but you won't be able to know whether the route or path will be same during the next call or not. Okay, it's like, suppose, like here. Now suppose this is a mobile. All right, this is communicating to another kind of, just imagine, to this laptop. This laptop is communicating with this mobile phone via WhatsApp call. Okay, now suppose this route was established among them. Okay, however, for this time this route was chosen. Suppose if there is another route, like from here to here to here to here, all right, you won't be able to know that the previous route that was selected will also be selected the next time then you make a call. There is a possibility that this route won't be selected the next time. Now this route, suppose there is a route here, now this route will be accepted for the communication connection. This depends on various factors, that which route is going to be selected. Basically, where traffic is less, that is less data is being transferred from that path, then that path is chosen for you for the best possible quality of service. All right, now the next one is message switching. What message switching is? Now what basically message switching is? So in message switching, suppose you sent a huge file to your friend from this laptop to this laptop. Okay, if you were making a call, then whatever data you were sending will directly be transmitted to this laptop. Suppose, because if data is of 1 GB, suppose it's just theoretically, if the data is of 1 GB, the whole data won't be sent in just one go. It has to be broken into small data packets, then it will be transferred. All right, so suppose your in message switching, what will happen is your data packets, which are made from the data that you broke into small pieces, is will first go to this device. This device has the responsibility to transfer your entire data to this laptop. So what it is going to do is, it's going to collect all the data packets first. It is not going to do like, if it received the first data packet, then just transmit it to the laptop. No, it's not going to do it like that. What it is going to do is, it's going to first collect all the data packets. Like, here comes the first one, here comes the second one, here comes the third one. It is going to first collect all of them. Then it is going to transfer it to the laptop, to the actual receiver, or maybe to the another router if there is. Okay, because in actual network there are several routers, several intermediate devices. So what they does is, in message switching, they're going to first collect your data all to themselves, then they are going to transmit it to another node. So this is what message switching does. Of course it's not for real time communication, because of course, in when you are calling somebody, you cannot wait that your any intermediate device is first collecting all of your data, then is transmitting your data to the actual receiver. That certainly is not going to be comfortable. Not comfortable, it's actually not going to be a communication. Then you're speaking something right now and the receiver is receiving it after a while. That's not going to work. So it is not used for real-time communication or applications. All right. So this is basically the story that I told you earlier. It's written over here. You can see if you want. Now, moving on to the actual switching that the internet uses. The actual internet uses this packet switching thing. What packet switching is? Well, basically, as I told you, internet is a packet switched network. In this, each message is broken into individual chunks. Suppose there is a huge message of 1 GB, it will be broken into small pieces, small chunks. Now, each of that chunk, each packet is sent individually. Okay, now that whatever you are sending, the packet you're sending, that packet will be containing the source and destination IP address, that is the sender's IP address and the receiver's IP address is with each packet. Okay, and also sequence number is also there with them. So it states the source and destination IP address is with each packet including with the sequence number. But now what sequence number does? Sequence number be like, if I'm sending 10 packets, they will be numbered like 1 2 3 4 5 6. So if somehow my first packet chose a different route and the second packet chose a different route, and somehow the second packet reached the receiver first then the first packet, so the order is disturbed. Now how to deal with that? So there's no need to worry when we have sequence number, because with the help of sequence number the receiver will know that this is the first one, this is the second one. We have to reorder the packets, so that helps in reordering the packets. You know which thing you have to put first. Then detect missing packet. If some message somehow get lost, then it can detect it, like the third message is not here, it is 1 2 then 4 5 6 7 8. However, there is no 3 here, so it must be lost. Then it will send acknowledgement for those who are received, and for those who are not received it will send retransmitting request. All right. Now I told you that packet switching has two approaches: datagram approach and virtual circuit approach. What are these? In datagram approach, datagram packet switching is also, first of all, datagram packet switching is also known as a connectionless switching. Each independent entity is called as datagram. Path is not fixed here. In datagram approach, the path won't be fixed. As I told you earlier, that data packet 1 could be choosing another route and the data packet 2 could be choosing another route. Okay, so the path is not fixed here. Not a connection is not first maintained here. That a route, a particular route is not first decided for your communication, that this will be decided for your communication and every packet will be following this route. No, it's not done here. Okay, now route is decided by intermediary devices to forward these datagrams. Each intermediary device is going to decide which route is at the time most probable for you, most auspicious for you. Then it will forward the data. Datagram have destination information and the intermediary devices uses the information to forward datagrams to right destination. Okay, so the data packets which you are sending, as I told you, are encapsulated with that sender's IP address and receiver's IP address. So they are encapsulated with some destination information, with the help of which they are going to reach the destination. All right. So this was about a datagram approach. Basically, it just, the thing here is that path is not fixed here, except some everything was most likely about packet switching. Similar. All right. Now, what virtual circuit approach is? This is also a connection oriented switching. Now in this, a pre-planned route is established. The difference is here, there was no pre-planned route. Here it is a pre-planned route before sending the message. Now here also we can take the example of telephone call. Suppose I am making a call via WhatsApp. Now a route will be first reserved for me. that all right, this route is suitable for their connection, reserve this for them. Every data packet that this guy is going to send is going to be received via this route. Now each and every data packet of mine will go via that route. So a particular connection is first established. Not like the previous one where there was no connection, where the path was not fixed. Alright. Now call request and call accept packets are used to establish the connection between sender and receiver. This is as I have mentioned to you. If you are calling your friend, so that call is first going to, if he accepts the call, that is, then it is going to establish a connection. However, if he is going to reject the call, then there is going to be no connection between you and your friend. Alright. The path is fixed for duration of a logical connection. How long you are going to talk to your friend, till then the path will be reserved for you. Path will be fixed for you. Alright. So yes guys, this was all for today. Thank you for watching this video.